Hey guys, Mr. Yisley here. So we are moving on to lesson number 9 in our chapter F, all about fractions. So you should be looking at the same page that you see on the screen. And so lesson number 9 is all about how to multiply fractions. So when it comes to multiplying fractions, kind of a 4-step process within that. The first thing we want to do is we're going to convert to a fraction if necessary. So if they give us a whole number or if they give us a mixed number, we need to convert it. So we're going to put all whole numbers that they give us over the number 1. So anything that they give us. So if they give us 6, it becomes 6 over 1, and that makes it a fraction. Right? If they give us a mixed number, we're going to switch mixed numbers into improper fractions. So now you probably understand why I've talked about in class so much that we don't really like mixed numbers, because the first thing you got to do with them is turn them into improper fractions to really use them effectively. So I'm really a big proponent of just leave it as an improper fraction if possible. So once we've switched that, made all those conversions, then in order to multiply them, we're just going to multiply across. So we're going to multiply the numerators. So multiply the numerators, so the top numbers times the top number, right? Then we're going to multiply the denominators, right? And we're going to go the top or bottom number times the bottom number, right? Then after we've got those, we're always going to check if we need to reduce the final fraction. So we need to check if we're going to reduce the final fraction. Now within this, most of the time, to be honest, if you multiply straight across, you're going to have to reduce at the end of it. Probably, I would say, about 90% of the time. If you're just multiplying straight across as is, you're going to have to reduce the final fraction. But we have what I like to call a simplification trick when we're multiplying. And what the simplification trick does is we're going to simplify the numbers before we multiply so that we don't have to reduce at the end. Right? And the way we do this is if the numbers diagonally, so we're talking about when we're looking at them, let's say that we've got right here 2 over 3 times 3 over 4. We're looking at this diagonal right here, all right? Diagonally across from each other. If they have a number in common, so something that divides into them easily, they have a common factor. So if the numbers diagonally across from each other, I don't know why that extra diagonally is there, I apologize, have a number in common. So if they have, or also known as a common factor, all right? If they have a common factor, you can reduce by dividing those numbers by that factor. Then you can multiply out after that like you normally would. Right? So we're looking diagonally across from each other and saying, hey, do these have any common factors? If they do, we're going to divide by that common factor, and that's going to be a little bit smaller. It's going to make the numbers smaller, and then the multiplication will be a little bit easier, and we shouldn't have to reduce at the end then. All right? So let's take a look at it. I'm going to do example 1 both ways. All right, I'm going to show you just multiplying across what it looks like, all right, on example A, and then I'm going to show you if we do the simplification trick. All right, so if we go first and we just multiply across, all right, first make sure that we have fractions and that there's no mixed numbers. We don't. All right, so we're going to multiply straight across the numerators. So 3 times 4, that is 12. And then we're going to multiply the denominators. 8 times 9, that is 72. All right? Well, then I need to divide those out because I know that they're both even numbers, all right, and that they are going to be able to be reduced. Well, the biggest number I know off the top of my head that works for both of them, all right, is 6. So I'm just going to divide them by 6. Well, 12 divided by 6, that is 2, right? And 72 divided by 6, that is 12. So I'm not quite all the way reduced down because, again, they're both still even numbers. So I'm going to divide them both by 2 again. Divide them both by 2. So 2 divided by 2, that's 1. And 12 divided by 2, that is 6. So I've got 1 over 6 as my simplified fraction. That would be my answer. And I apologize, you didn't see me writing any of that. So again, I went 3 times 4 is 12, 8 times 9 is 72, and then I divided both by 6. I got 2/12. Then I divided them both by 2 to get it to 1/6. All right, so now as I'm going to look at these, right, and as I'm going to work them out, right, I'm going to show us if we use this simplification trick that we were talking about. So if we look to simplify diagonally, how does that work? All right, so first thing I'm going to look at is this diagonal of 3 and 9. Is there a number that goes evenly into both? Well, I know that 3 goes evenly into 3 and it goes evenly into 9. So I'm going to go ahead and do that. So I'm going to write it down here over to this side. 3 over 8 times 4 over 9. All right, so we've got that right there. So again, I said 3 goes into both of these. So if I divide 3 by 3, I get 1. And if I divide 9 by 3, I get 3. Then I'm going to look at the other diagonal, so the 8 and the 4, and I'm going to say, all right, is there a number that goes into both of those? Well, I know that 4 goes evenly into both 4 and 8. So I'm going to divide both of them by 4. So if I divide 4 by 4, I get 1. And if I divide 8 by 4, I get 2. So now we're working with a little bit smaller numbers. And if I did this correctly, they should multiply across now to equal 1 over 6. So let's check. 1 times 1 is 1. And 2 times 3 is 6. So there's how that simplification trick can save us a little work, because we had to divide twice to reduce it down to 1/6 because of how big the numbers were and not knowing all of the factors of them, versus if I just do that simplification trick diagonally, I can get to 1 over 6. Now when it comes to your work, all right, and what you want to see on the assignment, either way is an acceptable way to solve these. All right, you can multiply straight across and then divide to get it down, reduce down, or you can use the simplification trick. Either way is fine, but you need to show which way you do it. You just can't write 1 over 6. You need to show the work of how you got there. All right, so let's take a look at example B. All right, example B, I notice right off the bat I'm multiplying fractions, but they are mixed numbers. All right, so my first thing I need to do is I need to change them into improper fractions. So first thing I'm going to do, multiply the numerator times the denominator. So 3 times 2 is 6, and then add that to the numerator. And I said denominator times the whole number, 3 times 2 is 6, then add 6 to the numerator. 6 plus 1 is 7, and then the denominator stays the same. So I've got 7 over 3. And then that's times, got to convert the other one, denominator times the whole number, so 2 times 5 is 10, then add that to the numerator, 10 plus 1 is 11, and then the denominator stays the same. Now, with multiplying fractions, remember, you don't have to have the same denominator. That really doesn't matter. That's only for adding and subtracting fractions. So at this point, I'm going to check, can I do a simplification trick? All right, so I'm going to look diagonally. So 7 and 2, do they have a factor greater than 1 that goes into both? Well, the only factor of 2 other than 1 is 2, and 2 doesn't go into 7. So I can't simplify that direction. All right, then I'm going to look at this one, 3 and 11. Do they have a factor other than 1 that goes into both? Well, the only other factor of 3 is 3, and 3 does not go evenly into 11. So I can't simplify this at all. Well, the great thing about the simplification trick is if we check for it and we are not able to do it, then that means the final fraction we end up with when we multiply is already in its simplest form. So I don't even have to check it now to see if it needs to be reduced. So I'm simply going to multiply across, and what I get for that is my simplest fraction. So 7 times 11 is 77, and 3 times 2 is 6. So final answer here is 77 over 6. Now I could convert this back to a mixed number, and as we talked about, I divide it in. So 6 goes into 77, goes into the first 7 one time. So, all right, that leaves a remainder of 1. 6 goes into 17 2 times, which means a remainder of 5. That's the top of my fraction over 6. So I could turn it into 12 and 5/6, right? But again, that's another extra step, and it's not required, all right? You can end at 77 over 6, and that is completely fine. Now, if you just love to have mixed numbers, then go ahead and make sure you've got it converted over to 12 and 5/6. But I'm completely fine if you end with 77 over 6. All right, well, I'd encourage you to try example C on your own, and then check your work with mine. So example C, I've got 6 times 1 2/3. So I've got both a whole number and I've got a mixed number. So I need to convert these into fractions, all right? And they're both going to be improper fractions, and that's completely fine. So my first one, my whole number, I'm going to write that over 1. So 6 over 1. And then that is times, I need to now take this mixed number and make it an improper fraction. So denominator times the whole number. 3 times 1 is 3. Then add that to the numerator. 3 plus 2 is 5. And then the denominator stays the same. All right, well, now I have the choice. Do I want to use the simplification trick or not? I want to use it. So I'm going to check diagonally and see, can I simplify? All right, well, I see 6 and 3. Do they have a factor that goes into both of them? Well, I know that 3 goes into 3 and it goes into 6. So I'm going to divide them both by 3. So 3 divided by 3, that makes that a 1. And 6 divided by 3, that makes that a 2. Then I'm going to look at my other diagonal, 1 and 5. Well, anytime you have a 1 involved, you know that you can't simplify any farther. But that's fine. That means the final fraction we end up with here is going to be our answer, and we don't have to reduce any further, potentially. So let's take a look. So 2 times 5 is 10, and 1 times 1 is 1. So we ended up with 10 over 1. Well, this is the one situation where this is not our final answer, because now we got to reduce or simplify it to its simplest form, and anything over 1 is just itself. So our final answer is 10. Every other time when we simplify like that, that fraction will be the final one. The only time we have to simplify it further is if it ends up over 1, we turn it back into a whole number. All right, well, that is how we multiply fractions. If you have any additional questions, please let me know. Otherwise, you've got what you need to continue on the playlist.